From small startups to large corporations, all face a common challenge when they want to utilize the power of large language models in their products and services. And that is, large language models require a huge number of resources for deployment or inferencing. Hence, accelerating the model inference is a major challenge for developers. And one of the most popular tools in the industry for handling this problem is vLLM. vLLM is an open source, highly performant engine for LLM inference, widely adopted across the industry with 18,000 plus GitHub stars and 300 plus contributors worldwide. And the power of vLLM is coming from paged attention that brings a classic idea of paging in an operating system's virtual memory to LLM serving. Without modifying the model, paged attention can batch 5 times more sequences together, increasing the GPU utilization and thus the throughput from the LLM. So when choosing our LLM inferencing technology stack or selecting a cloud GPU provider, if vLLM is powering the backend, that is a huge relief as far as fast inferencing throughput is concerned. Now let's quickly see how this revolutionary concept of paged attention makes all the difference for super efficient LLM inference. So the original problem was that the performance of language model serving is bottlenecked by memory. In the autoregressive decoding process, all the input tokens to the LLM produce their attention key and value tensors, and these tensors are kept in GPU memory to generate text tokens. These cached key and value tensors are often referred to as KV cache. And the growing KV cache demand with increasing sequence length has made LLM inferencing to be a memory-bound problem, significantly constraining the system throughput. So, efficiently managing the KV cache presents a significant challenge. And then to address this problem, the landmark paper on paged attention came along last year. Paged attention accelerates the key value caching for large language model inferencing by partitioning the attention mechanism's key and value matrices into smaller fixed size blocks or pages, allowing the model to selectively load and process only the relevant subsets of those matrices. This reduces memory overhead and computational cost, enabling more efficient scaling of the attention operation across a very large context. And that's exactly one of the major reasons why inferencing with vLLM is so fast. And beyond paged attention, vLLM is also famous for high throughput, which measures the number of output tokens a server generates per second for all users and queries. So vLLM can achieve up to 3.5 times higher throughput than the previous state-of-the-art TGI, that is Hugging Face text generation inference. And then talking about scalability, vLLM is designed to be scalable and has been successfully deployed by many players in the industry, including the famous chatbot Arena and Vicuna demo, serving millions of users with high throughput and low latency. And another of vLLM's strength is distributed inference and serving. vLLM supports distributed tensor parallel inference with Megatron LM's tensor parallel algorithm, and manages the distributed runtime with Ray framework. And the Ray framework is a unified framework for scaling and accelerating AI and machine learning workloads. And I also quickly wanted to mention about another very useful tool for LLM inferencing called C-Translate. This is quite fast as well, but the problem with C-Translate is that it does not support distributed inference just yet. So while vLLM supports distributed inference, which is something you will absolutely need for larger models. So overall, in my opinion, vLLM might just be the sweet spot for serving very large language models, especially when fast throughput is something that you want to achieve. Alright, now coming back to the main topic of this video, deployment and inferencing. The one that I have recently used a lot is Monsterapi. It definitely uses vLLM in the backend, supports deployment of almost all the popular pre-trained language model as a REST API endpoint, and any custom Docker image as a hosted Docker container. And definitely you can bring in your own fine-tuned language model to be served by Monsterapi. And this is also highly scalable, and a range of GPU options from 16 GB to 80 GB VRAM. And I think Monsterapi is probably the best LLM deployment solution that I have recently come across. It enables me to host both pre-trained and custom fine-tuned LLMs in one click on its cloud GPU. And Monsterapi provides several pre-hosted generative AI models indeed. I have used it for many of my use cases like quick question answer, data summarization, and sophisticated queries. You can get the API endpoints running very quickly within just a few minutes, literally, that can start serving text generation requests using models like Llama-3-8B or 70B, Mixtral 8x7B, or any of your custom fine-tuned models. Powered by vLLM in the backend, so super fast throughput, auto configures the entire pipeline for you, so you don't have to have any headache to set up anything. You can just hit the ground running within literally few minutes. And as per their official blog, they recently delivered up to 10 million tokens peak throughput for a very low cost of around $1.25 while serving Zephyr 7B model serving 39,000 requests per hour with an average request latency of 16 millisecond on a 24 GB GPU. And to get started with Monsterapi, you will need to create an account on their platform. So you need to head over to the sign up page. You may sign up easily via Google or GitHub or your own personal email, and you get free credits to start off. So I think they initially give you 2,500 credit, and that's kind of enough to do all your initial experimentation and to get to know the platform. And once you have created an account, they will automatically generate an API key for you, which can be found in your Monsterapi dashboard. And here I am in my dashboard. At the very top is a API auth key that has been automatically generated for me immediately after you have created your account in Monster Deploy. And on the left side, I have various sections for fine-tuning, datasets upload, deploy, billing, API docs, etc. And here there is some templates. All right. And if you go to deploy, and remember, deploy is still in beta, and you have to request by filling up a very quick Google form. It's a very fast process. As soon as you input your email and a couple of other information, and it gets sent to Monster Deploy, and they will approve you almost immediately, and you will get an OTP probably. And here are the various deployment option that is already there in the template. But of course, beyond these models that you see, most of the other models are supported indeed. There's a list of models actually in their documentation. It's very well written. And Llama-3-8B deploys Zephyr 7B, etc., etc. So I can already see the most popular ones right here. And at the bottom here, we'll show you all your previous deployment. Like currently live, there is nothing because just now there is nothing running, pending, building, completed, etc. Terminated by you. I have quite a few of them terminated because I was experimenting with them. And under the all section, you will see all of them. And even when they are terminated, you can just restart it by clicking on this on the right side 3 dots, retry deployment. And very importantly, they have a very exhaustively written documentation. So this is the main homepage of Monsterapi, developer.monsterapi.ai. And you can just browse through them. So for example, if I go to guides, this is the main documentation page. And then there's API reference. So here you can see for each of the API endpoints are very well mentioned. You can just go through them and the associated curl command, node.js command, Ruby, PHP, Python. So yeah, very well written. And then some of the important parts are if you go to guides and then you go to projects here. Projects using Monsterapi. There you will see quite a few already written, already built projects and well-written blog. Also the collab demo, Google Collab demo for each of them. So for example, here there's a list of deployment notebooks, Nose Hermes to Mixtral 8x7B DPO, deployed on A6000, 48 GB GPU. And right here, you can just do open in collab and it will run the entire collab. Open the entire collab and then from there you can launch it immediately. So there's quite a few examples here, and then these are actually full blog written for each of this topic. For example, Zephyr LLM with RAG, medical queries, auto blogger with Monsterapi. Yeah, so very good indeed. Under recipes, you can go there. Yeah, here also there's a ready-made quite a few recipes. For example, let's see this one, file upload. Yep, open recipe. Right, so what you need to do, for example, when you are uploading PDF files or any files while doing your deployment, because probably you want to build a RAG and you want to ask question to your API on your document. So here there's for Python, there's a relevant codes are there. Yep. And under API reference, here you will find model specific information. So you go to at the very top API reference tab. From there, you go to AI models, LLM models, and then you will see so many models listed. And for each of them, there's a model specific instruction. So for example, I'm in the Code Llama-13B instruct. It's a specialized 13B parameter generative text model built by Meta as part of the Llama 2 family. And then there are all the hyperparameters are explained here. So beam size, beam search is a strategy that considers a beam size most probable sequence at each step. So this one is a default number, what is the minimum and maximum number it can take, and format, and that is data type, etc. Max length, this is the maximum length of the generated code or text. 256 seems like the default number it will take. Prompt definitely is a string. Then repetition penalty, this helps the model to avoid repeating the same phrases or code. That is, when the model repeats, it will be invoked a penalty, and so that to prevent the model from repeating, so things like that. So probably you are already familiar if you are doing inferencing with LLM. Then temperature, top K, top P, all these things, and of course relevant Python code also given here. Also note that they not only support LLM, that is beyond language model, they have these image generation model, speech models. These are also supported. So text to speech Bark, speech to text Whisper, and for image generation you have pretty much everything. So you have your image to image, photo maker, instruct, pix to pix, SDXL, etc. Awesome. And one quick small note, I see that under the LLM models, I do not see the Llama 3, but actually Llama 3 is already supported by Monsterapi. It was the day it came, pretty much from that day, it is supported as a model for your deployment needs or fine-tuning needs. But probably the documentation is not yet updated, and they will probably, I guess they will update it pretty soon. So if you're planning to deploy with Monsterapi, definitely go through this documentation. It starts with these introduction section here, and yeah, so they say to sign up on Monsterapi platform easily via Google or GitHub or your email to create the account. After successful sign up, you will receive free API credits to explore. And just few more basic information on the API. So if you go to generative models API concept right here on that is the second section from the top, first introduction, then generative models API. So here they mention some of the basics like authentication pattern they use. Monsterapi uses bearer token authentication. Just include your API key in the authorization header for each API request. So for example, if you're using Postman, the tool for checking your API or testing your API endpoints, in the authorization tab, you need to enter the API, the auth token that you get from Monster into Postman. And then for the API request body, Monsterapi supports multiple content types in API request body, thus ensuring seamless integration with your workflows. Supported content types, application JSON, and multi-part form data. Again, these are very standard for API development and your pipeline. And while testing in Postman, just remember these details, because you have to put similar sort of things in your Postman configuration. And also definitely remember these applies to all the pre-hosted models, like what you already saw under the model section, that is LLM models. We saw quite a few models, right? Including Llama 3, all the variants of Mixtral 8X, 7B, etc. So all these applies definitely to the pre-hosted models, that is a pre-trained models, but also all of these absolutely applies to any of the fine-tuned model that you will bring to Monsterapi. So For example, you fine tune a model and then want to serve that monster API. So all these general principles and general mechanisms definitely apply to those custom fine tuned models. And I also wanted to point out about these file size, because when you are supplying or uploading files to Monster API, file size is limited to 8 MB. You can definitely send large files in API request. By default, our API handle files up to 8 MB. For larger files, you can either send a publicly accessible file URL or use our upload API. The API uploads your files to our S3 buckets and returns a download URL. And in your API page, you will see all these parameters defined, and you can actually, when you are actually sending the post request or the get request to your API endpoints, you can set the values for each of these parameters, and they are just the standard parameter values when you are working with large language models. For example, input variables, dictionary with input variables to use for generation. Prompt, this is the most important one. This will contain the entire string of your prompt. And stream, boolean value indicating whether to stream the result or not. Max tokens, an integer representing the maximum number of tokens to generate in the output. Then best of controls the number of candidate generation to produce from which the best is selected, only relevant when n is greater than 1. If none, the model will decide the best number internally. Presence penalty, frequency penalty, repetition penalty. Yes, that is also default is 1.0, a float that controls the penalty for token repetitions in volume. In the output, values of more than 1 will penalize and decrease the likelihood of repetition. Temperature, top P, these are very standard and well used parameters. Top K, mean P, use beam search, and that's another boolean value indicating whether to use beam search for generation. Beam search might provide better quality outputs at the expense of speed. And then link penalty, early stopping. Yeah, so all these values you can actually set when you are sending the post request in your API endpoint. And quickly have a look at their pricing scheme before moving further. So I am right now looking at this Monster plan, which is 39 USD per month. With this, you get 50,000 credit, up to 20,000 daily API calls, 10,000 image generation, 330 hours of audio transcription, 24/7 support, etc. All right, and you can actually calculate an estimate. Say, for example, you want whatever is your need. For example, I will choose Mistral 7B instruct v02. I need number of tokens to be generated per request. Yeah, let's keep it at 1,000 only. And total number of requests per month, let's keep it at something close to 100,000. So in this situation, you need $40.5 per month estimated cost. And if you increase it further, say for example 500,000, that would cost you $202,000. Sorry, $202.80 per month. And this is for Mistral 7B instruct v02. So if you choose a higher, larger model, I would definitely assume this price would increase. But anyway, still this pricing looks quite competitive and actually relatively less compared to many of the other options and that I have checked. Alright, now I want to show you this brand new feature of Monster API that they have introduced very recently, which is actually a super fast way to launch your deployment pipeline. And here you don't write any code, you don't even go to the deployment portal to change the configurations. Here you launch the deployment just by chatting in ChatGPT. So they have launched these new custom GPT called Monster GPT, and this is their official page. Introducing Monster GPT, world's first deployment and fine-tuning agent. Actually, with this custom GPT, you can do both deployment and also fine-tuning. And they have, and it's super simple. It's just only few steps. Will take few seconds actually. So if you just read their instruction for the deployment, deploy LLM part, there's also the documentation for fine-tuning LLM. But right now, I'm just going with the deployment. So you sign up to ChatGPT Plus. Of course, to use the custom GPT, as you know, you need a ChatGPT Plus subscription. So you sign up to ChatGPT Plus, launch a new Monster GPT chat, ask deploy code Llama-7B. For example, this is just an example. You can do anything. Choose any of the language model that Monster GPT supports and ask deploy code Llama-7B. Yep, that's it. And how Monster GPT works. So Monster GPT is a SOTA agent solution that allows you to skip the complicated technical setup required to deploy a fine-tuned LLM. With a simple to use chat-based UI, Monster GPT makes lives of developers easier. So it runs on Monster API. Yeah, it will in the back end, it will connect with your credentials and it will ask you question on the particular job that you want it to execute and also grab job logs, and you can definitely terminate it by just chatting with it. So let's just click on this, get started. And it will take me to my ChatGPT window. Yep. So it has automatically taken me to my ChatGPT window. Here, all I want to do is let's deploy Llama-3. So I only will tell it deploy Meta Llama-3-8B instruct and then send it to ChatGPT. And now it will ask me to provide the credentials, or I think in this case, it will ask me for the email. Yeah, exactly. That's what it asked me to deploy Meta Llama-3-8B instruct. Let's begin by authorizing your account. Could you please provide your email address to initiate the process? And then you just need to type your email and send it to ChatGPT and it will grab it. And then it will ask me, MonsterGPT wants to talk to Monsterapi.ai. Only allow sites you trust. So just click on confirm. Starting action. So it's working in the back end and talking to Monster API. I have sent an OTP to your email. Please check your inbox and spam folder as well, just in case, and enter the OTP here to proceed. And I see this OTP sent to my email immediately. So I come back to the ChatGPT window and just put the OTP here and send it to as a message. And again, it's working. And almost after waiting just for 1 or 2 seconds, it got me this Monster wants to talk to Monster API, only allow sites. Yeah, just confirm again. All right, after just confirming the OTP, it has started the process and now it is just taking the final confirmation before actually launching the deployment. So you have been successfully authorized. Now let's proceed with deploying Meta Llama-3-8B instruct. Based on the model specification, the deployment configuration will require base model path, GPU VRAM 48 GB, GPU count 1, prompt template, standard input-output templates. If you have specific templates or customization, please let me know. Shall we go ahead with the configuration or would you like to customize the setting? Yeah, just go ahead. Yes. Again, another confirmation. All right, and now it says the deployment for this Meta Llama-3-8B model has been successfully launched. The deployment is named Faithful Carver. You can expect to receive status update via email. Yes, so for each status of the deployment, it will send you email. So for example, right now, this is in a pending status because the launching machine is getting allocated, etc. So it will send you an email immediately with that status. And as soon as it goes live, you will get another email saying that it has gone live. So let's quickly check back my dashboard. Yep. So we can see Faithful Carver. This is the deployment job that I just launched. Currently, it says pending. That means it is just all the machines and required hardware, etc. are getting provisioned. And remember, when it is in pending status, it is not consuming your credit. Only when it is live, then it will consume your credit. Okay. So get back here. If you wish to check the deployment status or perform any further action, just let me know. So right now, I'm just waiting for it to go live. It may take 1 or 2 minutes. Let's just wait. All right, after waiting for like 1 to 2 minutes, my deployment is live right now, as you can see. And there's quite a few things you can do right from here because you need to open the actual API endpoint to check whether it's working or not. You can directly open from here, like just clicking here, open the API endpoint for this a new tab, and also you can copy the API endpoint from here and copy the API auth key as well, just in case if you want to test it, the API in Postman or in your actual workflow, for example, in VS Code or any other Python or Jupyter notebook. You need this API auth key, and let's just open it from here itself. But before that, let's quickly see the job info. So if you click on in this icon here, you will see the entire job info. Hard disk allocated is 96 GB. Deployment, this is the deployment ID, and this is the API endpoint. You can actually just copy from here. And otherwise, the deployment name, model name, LoRa path, I have not given any LoRa path, so it is showing an empty. A prompt template, that's my prompt template. It has taken by default this one. Of course, you can change it according to your requirement. And 48 GB is the VRAM that was allocated. And GPU count 1, API auth key, use nightly flaws, deployment ID. Okay, so that's it. Now I'm just going to click here and open the API. Yep, that's my API endpoint. So I have got a GET request and a post request option. So for generating the text based on your prompt, you need to send a post request. All right, now I'm going to actually test this API endpoint, and for that, the first thing I need is to authorize this API endpoint. So we already saw that Monsterapi uses bearer token when we are going through the documentation a few minutes before in this video. So to get the auth key, you just come back to your dashboard, and from here, copy API auth key. Okay. All right, now go back to the API screen, authorize, paste the auth key here, and authorize. Okay. Now you are authorized already. So the box has changed to log out. And if you just want to log out, you click here and it will again log you out. And then to test the API endpoint, just click here and it will tell you all the parameters and its definition. We have already gone through this. So let's click on try it out. Okay. And as soon as you say try it out, if you say that cancel, see this field is not editable. So as soon as you do try it out, all this field becomes editable, and you can edit each of this field because it's just a body that you are sending to your API endpoint, and all of them is very much defined here. So you can just read through them and change your values accordingly. So I'm going with the default value for now. I'm just going to change the prompt here. So the prompt I want to see, I want to ask this model, what's there in the dark side of moon? All right. And yep, so that's my body. That's the question I ask, and I just click on execute. And now it's loading, and my actual deployment is in work right now. It is sending the, yep, we got the answer quite fast. And so it just sent my question, my prompt, along with all these parameters for text generation to the model, that is a Llama-3 model. And this is the answer I got. So yeah, this is a response body. And the answer is the dark side of the moon is actually the side of the moon that always faces away from Earth, not the side that is dark or evil. It was incorrectly named the dark side because we couldn't see it from our planet. It was thought to be a mysterious and unknown region, etc. So yeah, very good answer indeed. Pretty much well written. And like I said again, that this is a public API endpoint. So this is your API actual URL of the API endpoint, and you can use it in any of your app, your website, or whatever. And you can check, you can do the complete API test in Postman as well. All right, so that's the API. Now I see that it's live here already. Now I want to terminate it. So let's go back to the ChatGPT because I'm just interacting with my API entirely from this custom GPT from my ChatGPT interface. I'm not doing anything else anywhere. I can control it entirely from the ChatGPT. That's a magic of it. So now I want to terminate the API. So I only says terminate the above live deployment. Okay, let's see what it says. Yep, it's just asking for confirmation. I just confirmed. Yep, the deployment faithful curve has been successfully terminated. If you have any more requests or need further assistance, feel free to ask. Okay, now let me check it was indeed terminated or not. So I go to my dashboard. Yep, faithful carver has been terminated by you. So you can see the log or the job info. So that's the one. So overall, it's really looking the next level. It's almost like magical that you are controlling your API deployment and the configuration, etc., completely from ChatGPT, and everything is working just fine. And I also quickly wanted to show you a deployment notebook because, like I mentioned earlier, that once you have your fine-tuned model, and then you can deploy your custom LLM, that is your fine-tuned LLM, as an API endpoint. And Monsterapi will provide you a REST API endpoints, which can then be integrated into any public web or mobile application. And this collab notebook I got from Monster itself. They have actually given quite a few example notebook in their site, so you can actually visit this page projects using Monsterapi, and there are so many examples for various situation, and for each of them there is a collab demo. So for each one you will have the complete code for you to run and deploy and see the effect. So let's very quickly go through this collab. It's only very few lines of code for actually deploying an API endpoint using Monsterapi deployment service. So first, of course, you need your API key, and then you need to install these pip packages, Monsterapi, and then bring in your relevant module from the Monsterapi. So here, this particular line is just bringing in the MC client, which is coming from Monsterapi package, because this MC client will manage your client-side code here. And to the MC client, you pass your API key. And this code is so simple. It's just basically you are defining few configuration. That is all. And once this deploy client is defined, you need to create an LLM deployment. And remember, this whole deployment is using this Code Llama-3-8B model with LoRa adapter that was previously fine-tuned. And that's what it is serving, that this notebook is serving. So to create the LLM deployment, first you need to define your launch payload configuration. So that is your base model path, your LoRa model path, and then prompt template, API auth token per GPU VRAM, GPU count, etc. And then launch the deployment with this line, return deployment client, deploy client dot deploy. And then you pass your LLM and launch payload that you just defined. And that will give you a deployment ID. You can print that deployment ID. And then these are various deployment status. That is, for example, below mentioned are different types of status responses. So in progress, status pending, status failed, then building, and finally live. This is the most important one. That means everything is just live. And this status is for terminated user, because after your deployment time is over, you need to kill it by terminating the deployment. Okay, so once the deployment is live, let's query our deployed LLM endpoint. So this particular code is just for querying. So first you check with this assert line that the deployment status is live. And then service client is coming from MC client. Base URL status return dot get URL, and then here you defined your payload. Here the input variable, your prompt goes write a Python script that reads from CSV file and output to JSON file. Okay, and then I get the output from the model with this line, service client dot generate, and then I am doing this payload dot get stream for I in outputs, print I0. And this is what it outputs. Let me see the output in more detail. Yeah, this is the output I get. It's defining the method right here. Okay, now one thing I wanted to point out is at the very top when I'm defining the base model path and the LoRa model path. So here the theory is that once you have fine-tuned an LLM on Monsterapi, you will receive the adapter weights as the final output. This adapter contains your fine-tuned model's weights that Monster will host as an API endpoint using Monster Deploy. And Monster Deploy optimizes its, and that's the reason I am passing these base model path and the LoRa model path. So the LoRa model path is actually the adapter weight. This is a zip file. And Monster Deploy optimizes its backend operations using the vLLM library. vLLM currently is the most popular library for fast inferencing on a large language model, and it's especially notable for its state-of-the-art serving throughput. And so that was a quick deployment code here. And of course, the last line is for termination of the deployment, because once you are done using the deployed model, don't forget to terminate your deployment and thus avoid billing charges. So it's a single line of code right here, and your deployment client will be terminated. So that was a quick description of the deployment with Monster Deploy API, and definitely check out the documentation here. It's very well written. All right, that's a wrap for this video. Do check out their site, and I will put all the links in the description. And thank you very much for watching. See you in the next one.